Lesson 77, it says using the law of cosines. We did law of sines in the last few lessons, and that is always the one that you want to use if you can use it. If we look at this triangle here, we want to solve for angle A, angle B, and side BC. Well, what I see first is I have a side and an angle that match up here, so I need to, it would be easiest to use the law of sines here. And remember what law of sines is you put the side length over sine of the angle that it matches up with equals, and say we're going to use this 29 here and find angle B, so 29 over sine of B. Alright, so to solve for B here, remember we cross multiply, so 22 sine of B equals 29 sine of 32. Okay, so we type that into our calculators, 29 times sine of 32 equals approximately 15.4. Then we have to divide that by 22 to get approximately 0.7. And then we have to take the sine inverse of that answer to get the answer of 44.3 degrees. Once we have that one, then we can solve for angle A, because we know that A, B, and C have to add up to 180. So if we take 180 minus 44.3 minus 32, we get an answer of 103.7 degrees. And now that we have that angle, then we can find this side by going 22 sine of 32 equals x over sine of 103.7. Alright, and then we can cross multiply here. Sine, or 22 times sine of 103.7 equals sine of 32 times x. So to get x by itself, we're going to take 22 times sine of 103.7, gives us approximately 21.4, and divide that by sine of 32, which would give us an answer of 40.3 for our side length there. Alright, so we've found angle A, angle B, and side BC. Now we need to try and find the area of the triangle. Now remember, I showed you when we did sine law, the easiest equation to use would be the area equals 1/2 times one side times another side times sine of the angle in between. Alright, and when we do that, we get 309.9, and we don't have a label, so it's units squared. Alright, now, say you didn't want to do that one. Say you wanted to use this combination. Those three, we would take 1/2 times 22 times 40.3 times sine of the angle in between, and we get 309.6, which is approximately the same as the 309.9. The difference between the two is just the rounding errors that we would have built into this one. Alright, so this works with whatever combination we want to use as long as those three are together. It doesn't matter which three it is. Alright, now, what happens if, for the last one, we had a side and an angle that matched up? What happens if we don't? We don't have this here. We don't, across from 32, we don't know. Across from 84, we don't know. And across from 43, we don't know. Alright, when that is the case, we are going to use what's called cosine law. And this looks complicated, but as long as you understand the pattern to it, it is much easier. Alright, now, take a look at these three equations. I know they're all written differently. They all mean the same thing. Okay? Say that we are starting with this angle here. Okay? We would end up using this one here. Alright, and what this is, if you just look at the first part, ignore this after the minus sign, we have a squared equals b squared plus c squared. That looks very similar to Pythagorean theorem, or if you look down here, a squared plus b squared does equal c squared. That is Pythagorean theorem. After that, we would subtract out 2 times one side times the other side times cosine of the angle. Alright, so let me show you what that looks like back here on this one. Alright, we've got 2 sides. We need to figure out what the third side is. Alright, now, for that, okay, we're going to use, here's our equation, c squared equals a squared plus b squared minus 2ab cosine of c. Alright, now our c is this x here, so we've got x squared here, equals, a and b, it's one of these two, doesn't matter which one, so 32 squared plus 43 squared minus 2 times 32 times 43 times cosine of the angle in between them, which is 84. From there, you can type it all in your calculator. So we've got 32 squared plus 43 squared minus 2 times 32 times 43 times cosine of 84. So then we get x squared equals approximately 2585. And then remember, to get x by itself, we have to take the square root of that to get an answer of 50.8. After we're done with that, we still have to find these two angles here. Alright, from there, we have a side and an angle that match up, so we can do sine law. So we've got 50.8 over sine of 84 equals, and then say we want to find angle E, we've got 43 over sine of E. So we cross multiply 43 sine of 84 divided by 50.8 gives us 0.84, and then we have to take sine inverse of that answer to get approximately 57.3 degrees. And once we have that one, we take those, add them together, subtract them from 180, we get an answer of 38.7 degrees. Alright, so sine law we want to use whenever we can. Cosine law we might have to use to get us started here. Alright, now if we go to the next one here, we can do this when we don't have any angles at all. We have a triangle with side lengths of 11, 12, and 19. Find the measure of angle Q to the nearest tenth. So, there's the angle we want to find. Alright, which means the angle we want to find, the side opposite it, is going to be on the left side of the equal sign. So we've got 19 squared equals 11 squared plus 12 squared minus 2 times 11 times 12 times cosine of Q. Okay, now from here we need to do order of operations. So 19 squared is 361, I believe. 361 equals 11 squared is 121. 12 squared is 144. Okay, minus 11 times 12 is 132 times 2 is 264 cosine of Q. Okay, from here we can add these two together. So we get 265 minus 264 cosine of Q. Now, what a lot of people do is, we know by order of operations, these two things are multiplied together, so these two cannot be combined. We need to subtract the 265 over to get 96 equals negative 264 cosine of q. And then we divide by negative 264, and then we take the cosine inverse of that answer, and we get q equals 111.3 degrees. Alright, so there's our cosine law. For this one down below, given triangle XYZ, x equals 4, y equals 6, z equals 7, find angle x to the nearest tenth. So we need to draw a triangle, it doesn't matter what it looks like. So we've got x, y, and z there. From there, we need to label up our sides. Alright, now if we have angle x on the top, we would put side x on the bottom. If we have side or angle y on the left, we need to put side 6 over here, and then that would put 7 here. We want to find angle x. Alright, so it's very similar to the one that we did up here. Alright, so we've got 4 squared equals 6 squared plus 7 squared minus 2 times 6 times 7 times cosine of x. So once again, order of operations, 16 equals 36 plus 49 minus, looks like 84 cosine of x. Alright, and then we need to move the 36 and the 49 over to get a negative 69 equals negative 84 cosine of x. So negative 69 divided by negative 84 gives us a positive 82, and then we have to do cosine inverse of that to get an answer of 34.8 degrees. Alright, next one. Alright, now what we just did, this is just like the triangle of the last one. So if we know angle Q is 111.3, which we can find by cosine law. Technically, to find the area of the triangle, all we'd have to do is go 1/2 times 11 times 12 times sine of the angle in between, and that would give us the area of the triangle. So if we multiply that out, we get an answer of 61.5 units squared. Well, another way to do it is by what's called Heron's formula, and if you want to memorize this, you can. As I just showed you, there's another way to do it. But Heron's formula would help you find the area by just using your side lengths. Alright, and the equation is A equals the square root of s times s minus a times s minus b times s minus c. And s equals 0.5 times a plus b plus c. So what we need to do here are a, b, and c are any one of these three sides. So what we need to do first is we need to find out what s is. So that'd be 11 plus 12 plus 19. So add those three together, divide or multiply by 1/2. And we get s equals 21. Alright, and then we use the other part of the equation. So we'd have 21 times s minus a, so 21 minus 11 would be 10. 21 minus 12 would be 9. And 21 minus 19 would be 2. If we multiply those four numbers together, and then take the square root of that, we get an answer of 61.5 units squared. The area for both of them works. This one is how I would do it most of the time. Okay, if you want to memorize Heron's formula, yep, it can be fast and simple to be able to do. Alright, but it's another equation to memorize that, to be honest, we don't use very much. Alright, so take a look at it in the homework. If you have any questions, let me know.